All right, so one more quick review from Algebra 2, and then we get to play in the sandbox with some really cool absolute value stuff. So this is called a piecewise defined function, or just a piecewise function. All right, so a piecewise defined function. And what it says is that this is a combination of three different functions depending on which interval you're looking at. So let's go ahead and graph each of them independently, and then we'll put it together as a piecewise function. So let's look first here at the second. Well, this is a parabola, upward facing parabola, because it's a positive number out front, and the 3 tells us that we're going to squeeze. So the output that was a 1 is now a 3, and so there's no translation up or down or right or left. The second function, and let's try to keep them about the same size. The second function is just the constant function at -1. Right? It just goes on forever. This is y equals -1. And then the third function is the one that's a little bit more complicated. And this one says there's no squeeze or stretch. There's no a value out here, which is convenient. It just says that all the points are going to move to the right 5 units and up 2 units. So if I take 0, 0 and go to the right 5 and up 2, I end up at, well, let's see, where do I want to put this? At 5 and 2. And then the 1, 1 point, if I go forward 5, I end up at 6, and if I go up 2, I end up at 3. And then the -1, 1, I said parabola, I think, but what I meant actually was this parent, the parabola with the arm bent down. And then the -3, -1 point, well, -1 goes forward 5, so I'm at 4, and then it's here, so I'm at 4, and then the -1 point goes up 2, and I'm at 1. And so it looks kind of linear. It's up to you to remember that we're actually talking about that function right there. Okay, so now let's put it onto its own graph. Let's put the parts where they belong on their own graph. So the first one, I only want the interval from x values less than -1. So if this is -1, I really only want to graph this part of it here. So I think I can use my technology to make that happen. So I'm going to bring this down to right there. Then on my second graph, I only want -1 on the interval from -1 here, including -1, and then all the way up to 4, but not including 4. So let's see if I can snag that. I think I'm going to get the whole thing. This can be tricky. It's not exact technology. There we go. And now I'm going to move this. So it's going to be in the same location it was before, but notice that for the middle part of the function, at -1, it's defined on the interval from -1 to 4. So the upper part of the function is not defined there because it's strictly less than. Okay, so let's put on the last piece now. I'm looking at, oh, I copied that wrong, sorry. X is greater than or equal to 4. So we want to figure out where 4 exists. Well, if this is 5, 2, then 4 should be just this side of it. So we're really talking about this part of the function, right, from 4 to infinity. And, okay, that darn technology. Now if I move that into position, and then I have to decide whether or not the 4 is included on this part of the function. And in fact, x is greater than or equal to 4, which means that the 4 is included. We knew that already from this part, but just in case, we're going to double check. So we know that at 4, the function becomes the third part, or the cubic function. And over here, this is at -1. So that's graphing the piecewise defined function. So now let's move to the play box, to the sandbox, and play a little bit with absolute value. Now, we know from our parent graphs that when y equals the absolute value of x, we get the graph that looks like this. But that's not what we're going to play with. We're going to play with not having x inside of the absolute values, but having other things inside of the absolute value. So let's start with y equals, let's say x squared minus 4. So this is just a parabola that has slid down 4 units. So I know that I'm going to intersect at the y-axis at 0, -4. The 1, 1 point is going to slide down 4 units and be at 1, -3, and the same thing for the -1. -1, -3. And the parabola looks like this. Now, here's the cool part. What happens, the question is, what happens if instead of putting the absolute value around just the x, we actually define a new function where the function is in absolute values? Let me be a little bit clearer. So we're going to call this function, we're going to use a different notation. We're going to use the f of x notation. F of x equals x squared minus 4, and this is the function that we've defined, right? So now I want to find a new function called g of x, which equals the same exact thing as f of x, right? So the exact same parabola, except I want to turn that absolute value. So what would g of x have to look like? Well, what would that say? That would just say all of the output values, because f of x is the output values of the original, all of the output values will be flipped from being negative to being positive, because it's about distance. So instead of being on the negative side of the graph, they'll change to be on the positive side, because distance is always positive. So let's look what that graph would look like, and I'm going to put it on a different grid. So I like that technology I used before, so let's see if we can make that work again. So this part of the graph is going to stay the same because these have all the positive outputs anyway. Okay, so let's see. Let's move them. I'm not entirely sure how to capture both of them, but let's give it a shot. I bet I can figure it out. There we go. So we're going to move these down here because we like those. That's the part of the graph of f of x that's already positive. Now we want to take the part of f of x that's negative and then flip it. So again, not really sure about my technology here. I think I have a button. I'm going to go on, put you on pause for a minute. I do. I'm going to do the flip horizontal. No, flip vertical looks like. Yes. And so now that just moves up here. Now I ended up with all kinds of extra stuff, so I probably don't need that. Let's go ahead and put it back up here where it belongs. Okay, so look what happened. I took the parabola that always existed and I took all of the negative parts and turned them positive. So I get this funky shape that has this little cutout. How cool is that? It's a very fun way to play with a graph. Okay, that was one way of playing. Now let's look at another way of playing with absolute value. So let's define a new f function. I'm going to work with the parabola again, but this time I just want to put it here. And so this is the f of x equals, and let's just call that x, doesn't matter really what the input is for this, the f of x equals x minus h squared. So I'm seeing an error in my method here. So this will be h. So I've moved forward because x is cattywampus. I've moved forward to h. And now I want to define a new function, a g function, where the g function uses the f function, but we want to take the absolute x values. So in this case, I'm going to get the same function. I'm using the exact same function, but every time I get a negative x, or every time I would have put in negative x in the initial function, I'm going to change that negative x to a positive x. And so what would that effect be? Well, this part of the graph where I'm choosing positive x's, no change. So this part of the graph has no change at all because I'm choosing positive x values. So I'm just going to move that back over there. All right, but on the other side, notice that this is the output that I got for all of my negative x values. I got this output over here. But in this case, I don't really want those because I'm not going to choose those. Every time I choose a negative x, I'm going to get the result that would have come from the positive x, the same result that would have happened from the positive x. Oh, yikes, what happened there? I tried to delete just my little... There we go. Yikes. Maybe I have to... There we go. Okay, we're all caught up. All right, so now what I want instead is I want to pick these values are the outputs I'm going to get. So when I choose -1, I'm going to get the same output I would have gotten with a +1. And when I choose -2, I'm going to get the same output I would have gotten with a +2. All right, so what I'm going to get is a mirrored reflection on the other side. Let's try it this way. Let's try a copy and then a paste. And I found my button before that lets me flip. There we go. So then it's going to mirror on the other side. So I'm going to get exactly the same thing, except I get a mirror on the other side over the x-axis. Also very cool. And then of course we could do all of our standard translations on these fun new graphs. So in this case I would have my new graph could be g of x equals, oh, let's not use that notation, hang on, y equals 3 times, which would squeeze or stretch this, the g function of absolute x minus h plus k. So inside of the absolute x minus h of the g function, I would get a right and left shift on the x-axis, I'd get an up and down shift on the y-axis, and a squeeze and stretch. But let's save that for another day. Just interesting to note that even when you're dealing with a function of a function, you can do the same things to it. And I can't think of anything funner to know than that.